All right, we're back again with projectile launching. We're going for an angle launch, and we're just trying to get a feel of how long that object's in the air. Number one, if it's on a cliff, let's go ahead and put this here. Actually, let's go ahead and put the equation here. We have y equals y naught plus initial velocity in the y direction times time, and then minus 0.5 gt squared. Okay, so if, let me write it down here, oops. If the projectile has an vertical displacement of 0, it's easier. Okay, so y minus y naught is going to be equal to 0. Okay? So if that's the case, then you're going to factor out a t and solve using zero product property, and I'm not going to do that right now. Okay, well, not the whole thing, just a touch. Just a second. Boom. Copy this. I better put t in property. Okay, so if their initial displacement is 0, then y minus y naught is 0. And you can factor out a t and have it be t. Factor out one of these t's, there's still going to be one left over. And then you can solve for t. Okay, just to kind of give you a feel there. Now, if, for some reason it's not wanting me to hit enter here. Doesn't like number 7. There we go. So if there is a vertical displacement, then use the quadratic formula. Okay, how does that work? What's going on? We have this t, these t squareds, we have a whole bunch of things in here. So let's go ahead and have this equation that we had originally. Trying to write it most general in here, that's why I'm not using the h's. I'm just using the y's and y naughts, okay? So in that case, let's go ahead and take a look at what is the quadratic formula. I'm going to do it over onto the right because it's a little easier to draw with by freehand. So I know the quadratic formula is ax squared plus bx plus c equals 0. I can use it when I have an x squared term, an x, and a constant. That's when it works the best, and that's when it's most useful. So I can find x equals a negative b, and then you have the plus or minus component, b squared minus 4ac all over 2a. Now, why would I even want to use it? Well, let's take a look at this equation. I'm going to set this equation equal to 0, and I'm going to throw everything onto the left side so I can make the a value positive here. What do I mean by a value? That looks like something times x squared, right? Except it's not an x, but that's okay. Then I'm going to say minus v naught yt, and then plus y minus y naught equals 0. So let's figure out what that b term is here. it'll be a negative, so let's say plus negative. And then the c term, that's going to be y minus y naught. So a equals a half of gravity, b equals the negative velocity in the y direction, c equals the displacement. And you can find out what the time is. So the time is equal to a negative v naught y, so turn that into a positive, plus or minus the square root of v naught y squared minus 4 times 0.5 times g, that's the a, and then the c is the displacement. All over 2a. There we go. So you could find out the time the object is in the air. Please do not memorize this formula. Know how to take the original equation and pull it to find the time. And you can go ahead and do any type of projectile in this manner. And interesting to note, there's a lot of cool things you can look at that quadratic formula to see when would this be equal to 0, and very interesting how it seems to be similar to our v squared equation. This v squared equation needs to have a 2 here. Okay. So just to kind of show you that they're very similar there. And initial velocity in the y direction. If you have a horizontal launch, what does this do? So good things to think about is if you have horizontal launch, what would that do with this scenario? And also, what would you do if you had the final velocity? And how that's similar to that square root, that determinant there. What's it underneath the square root? Okay, hope you had a great day. Hope this helps.